Reversal of rotation. Reversal of rotation in an AC induction motor is very simple. We need to remember that swapping the supply isn't going to do anything because it's already being supplied by a swapping supply, in other words AC. Now when we look at the actual motor, we will see that the motor consists of two coils, a running coil and a starting coil. Now your typical configuration would be that these two are simply placed in parallel with each other. But now in order for the reversal of rotation to occur, what we do is we select one of the coils and we reverse the polarity on only one of those coils. In other words, in order for reversal to occur, I connect my running coil directly to my supply voltage, but my starting coil I will reverse the polarity of. In other words, I am in essence I am doing that with my motor. So now by reversing the direction of my connection on one of the coils, what is actually happening is I'm reversing this polarity. And because I'm reversing this polarity, when it comes to the actual motor, where that would have been north and south and north and south, I am now starting off with a south and a north. And as a result, the rotation will change. You're welcome to go and do that with reference to part 3. Before we can connect a motor to a supply, we first need to test that the motor is safe for operation. First is our visual. There are two tests that needs to be done. A visual inspection and an electrical inspection. The visual inspection, that includes a mechanical inspection of the motor, and there we're going to look at stuff like the termination box. We're going to look at the foot piece. We're going to ensure that all nuts and bolts are correctly fastened. Cooling fans are installed correctly. All covers are closed. We're going to ensure that it's clean and dust free. Ensure that the axis of the motor isn't bent, that there's no burnt wires. And so forth. Another important thing to test is that the axis is running freely. In other words, we're checking the bearings. Okay. Once we're done with the visual and the mechanical inspection, the mechanical test, we're going to continue to the electrical testing. Now when we conduct the electrical testing, we need to use a measure and the measure we are going to set to 1.5 times the operating voltage that the motor is going to experience. So in other words, if we're going to connect it to 240 volts, we're going to multiply that 240 by 1.5, and that is going to give me 360 volts. So that is the minimum voltage I need to set my mega to. Now when we conduct the tests, our motor has the starting coils and the running coils, and depending on the model or the make or the type of motor, it might have a capacitor, and it will also have a centrifugal switch, which is normally closed. Now the first test that we're going to conduct, first electrical test, is we're going to test the continuity of windings. In other words, we want to make sure that these windings are correctly or are correct and that they work properly. So we're going to take our measure and we are going to connect it to our first coil, and we're going to take a reading, and then we're going to connect it to the second coil and we're going to take a reading. You'll note that none of the components that make up the motor are actually connected to anything. Okay, so we're testing the resistance of the first coil and the resistance of the second coil. One of them will be a large value or a larger value than the other one, which will be slightly smaller. The sizes will distinguish which is the starting coil and which is the running coil. Once we've done the continuity of the windings test, we're going to test for the insulation resistance between the windings. Okay, what we do there is we take our mega and we connect it from one coil to the other coil and we run a test. If there's any electrical fault between these two coils, then I will get a reading. If the test is done and I measure infinite ohms or an open line set value on the mega, it means that there is no electrical connection between these two coils, and that is what we want. We also test the capacitor. Before testing the capacitor, we will go and short circuit the capacitor to ensure that there's no charge. Then we will connect the mega on there and we should get a low value which very rapidly increases towards infinite. When we test the centrifugal switch, we should get 0 ohms on that switch, or very close to 0 ohms on that switch. The last test that we do is our insulation resistance to earth. And for that we're going to take our earth terminal and we are going to connect our motor to the earth terminal on the one side, and we are going to conduct tests to all the other components to ensure that all my values are infinite or open line conditions, because we do not want any electrical connection to the earth contact. If it is, then it means that there's a fault, that one of the components or that specific component actually does touch the housing of the motor, which is an electrical problem.